Beyond the silence of space, a living world shines like a jewel in the darkness.
This is Earth, a planet shaped by water, fire, ice, wind, and the endless passage of time. From above, its continents appear familiar, yet hidden within them are places that seem almost impossible. Across this remarkable world, nature has created landscapes beyond anything imagination could design.
Some were carved slowly by rivers of ice, moving with silent and unstoppable power. Here, ancient snow has been compressed into frozen monuments thousands of years old. Along the frozen edges of the continents, ice becomes architecture sculpted by wind and sea. What we see above the surface is only a fraction of the hidden world below. Each frozen giant begins a quiet journey, carried toward the open ocean by powerful currents.
Even in apparent stillness, the frozen world is constantly moving and changing. When darkness returns, the sky itself begins to dance above the sleeping ice. At the edge of morning, color returns to a world that once appeared almost without life. Every summer, flowing water discovers new paths through the heart of the ancient ice. Within these frozen chambers, ordinary sunlight is transformed into an extraordinary blue glow. Yet beneath the frozen surface of our planet, another force is always waiting to emerge. Fire rises from deep within the earth, melting stone and reshaping everything in its path. Even the hardest landscapes remain temporary when confronted by the heat of the planet's interior. Where fire meets water, destruction becomes the beginning of entirely new land. By morning, the ocean begins its patient work of cooling and shaping the newborn coast. These mountains stand as reminders that the ground beneath us is never truly still. In volcanic craters, heat, minerals, and water combine to create colors that appear almost unreal. Here, the hidden energy of the planet reaches the surface in clouds of vapor and flowing mineral water.
From the high mountains, water begins another journey across the continents.
Drawn by gravity, small mountain streams gather strength and carve passages through solid stone. At the edge of the cliffs, rivers surrender to gravity in some of nature's greatest spectacles. For a brief moment, solid rivers are transformed into clouds of light, movement, and sound. In remote valleys, countless waterfalls remain unseen, flowing through landscapes untouched by time. Clear water connects the mountains to distant seas, carrying life through every landscape it crosses. Seen from the sky, rivers become living patterns, constantly redrawing the surface of the earth. Before reaching the ocean, water creates vast sanctuaries where countless forms of life gather. Beyond the fertile waterways lie regions shaped by absence, where rain may not fall for years. In the desert, wind becomes the artist, rebuilding the landscape grain by grain. These moving mountains appear permanent, yet their shapes may change with every passing storm. Elsewhere, ancient lakes have vanished, leaving behind horizons where the earth and sky become one. As the water disappears, minerals create repeating patterns across an endless natural canvas. In these dry lands, exposed stone preserves stories written across millions of years. Flash floods and drifting sand have polished these hidden chambers into flowing walls of stone.
When the heat fades, the desert opens beneath one of the clearest skies on Earth. Far from the desert, abundant water creates worlds overflowing with color, movement, and life. With the arrival of morning, the forest awakens from the canopy to the dark ground below. Every layer of the rainforest offers a different world, shaped by light, height, and competition.
Even the smallest details reveal the extraordinary beauty created by constant warmth and rain.
Beneath the towering trees, clear streams carry cool mountain water through the humid forest. Rain is the pulse of this ecosystem, returning again and again to sustain its immense diversity. As quickly as the storm arrived, sunlight returns, and the entire forest begins to shimmer.
From above, the river appears as the great artery of a living green world. Eventually, every river completes its long journey and becomes part of the sea.
Along the coasts, waves and weather have sculpted stone into natural fortresses above the sea. Every cave, arch, and isolated pillar records the ocean's patient strength.
Where land and water meet, the shape of the planet is rewritten with every wave.
Below the waves lies another world, as complex and colorful as any landscape on land.
Here, thousands of individual lives move together as though guided by a single mind.
Beyond the reef, the seafloor falls away into a vast blue realm that remains largely unexplored. Across the oceans, isolated islands preserve landscapes and species found nowhere else on Earth. On these remote summits, clouds, mountains, forests, and oceans become part of one interconnected world.
Ice, fire, sand, forest, and sea may appear separate, yet each belongs to the same living planet.
Its beauty is never fixed, for light, weather, and the changing seasons transform every place. Sometimes, for only a few moments, the elements align to create a scene that feels like a dream. Our journey will cross this extraordinary world in search of its most unbelievable natural wonders. These places may seem impossible, but they are real, and together they form the only home we have ever known. Far across the North Atlantic lies an island where two of Earth's greatest forces exist side by side. This is Iceland, a young and restless land shaped by frozen water and fire from deep within the planet. Across the island's highest regions, immense glaciers preserve thousands of years of frozen history. These rivers of ice move slowly toward the sea, carrying the dark memory of ancient volcanic eruptions. Seen from above, the glacier becomes a frozen labyrinth of ridges, fractures, and hidden depths. During the brief summer, flowing water searches for passages into the heart of the ice. Below the surface, hidden tunnels form and disappear as the glacier continues its silent journey. Layers of ash trapped within the ice reveal moments when fire once darkened the Icelandic sky.
Even within this frozen chamber, change never stops, arriving one drop at a time.
Beyond the darkness, the glacier releases its water into a landscape created by countless cycles of freezing and melting. At the glacier's edge, fragments of ancient ice begin their final voyage toward the ocean. Every iceberg carries a unique form, carved by pressure, temperature, wind, and water. For Iceland's wildlife, this changing boundary between ice and water offers both shelter and opportunity. As the ice melts and shifts, hidden surfaces rise briefly into the daylight.
Carried by the tide, the glacier's broken pieces move steadily toward the sea.
On the black shore, ancient ice becomes crystal, shining for a final moment before returning to water. Here, the ocean and glacier complete a cycle that has continued for thousands of years. Beyond the shore, meltwater spreads across volcanic plains in constantly changing patterns. Water escapes the ice with growing power, cutting new paths through layers of volcanic stone. Across Iceland, countless rivers reach sudden cliffs and fall into the valleys below. Behind the falling water, the familiar world becomes a shimmering landscape of light and mist.
When sunlight enters the mist, the waterfall transforms into a moving prism of color.
Some waterfalls remain concealed within deep canyons, protected from the world beyond their walls. After the rain, entire cliffs awaken as temporary streams descend toward the lowlands. Here, cooling lava once fractured into geometric walls, and rivers later claimed the passages between them. Along the coast, volcanic stone reveals patterns created as molten rock cooled and contracted. Offshore, isolated pillars stand against the full power of the North Atlantic. When the storm passes, Iceland's cliffs become crowded sanctuaries for birds returning from the sea.
Puffins cross the open water again and again, gathering food for their hidden nesting burrows.
During the short northern summer, these remote cliffs become one of the island's busiest communities. Away from the coast, new life gradually covers the scars left behind by ancient eruptions. The recovery begins on the smallest scale, as moss finds shelter within cracks in the lifeless stone. Over centuries, barren lava is softened by water, weather, and the patient return of vegetation. Few land mammals are naturally equipped to survive this island's cold winds and rapidly changing weather. For the Arctic fox, every ridge offers a view across a territory shaped by both abundance and uncertainty. In Iceland's highlands, mineral-rich mountains display colors rarely seen together in nature. Beneath these valleys, underground heat warms water trapped within the fractured crust. Here, Iceland's hidden heat reaches the surface through boiling mud, mineral springs, and clouds of vapor. Every bubble is driven by heat rising from a vast geological engine beneath the island.
Heated underground, water returns carrying dissolved minerals that paint the land in unexpected colors.
When pressure becomes too great, the trapped water escapes in a sudden eruption of steam and liquid.
From above, the steaming basin reveals how closely Iceland's surface is connected to the heat below. In this land of extremes, warm rivers can flow beneath mountains that remain covered in snow. Iceland stands upon a boundary where enormous sections of the planet's crust slowly pull apart.
The evidence of this movement is written openly across the land, in valleys, fractures, and broken stone. Across the interior, volcanic cones mark the places where molten rock once reached the surface. Inside each crater lies a record of pressure released from far beneath the ground. Sometimes the quiet surface breaks open, and Iceland's creation begins again.
Molten stone advances across the plain, following every hollow and surrounding every obstacle.
At the surface, the lava begins to cool, while liquid fire continues moving beneath its fragile crust.
For a brief moment, winter and volcanic fire meet within the same cloud of steam.
By morning, the eruption has created a new surface, dark, fragile, and almost entirely lifeless. From this beginning, weather and life will spend centuries transforming bare stone into living ground. When winter returns, snow temporarily conceals the island's dark volcanic foundations.
The Arctic fox changes with the season, becoming almost invisible within the frozen landscape.
Under the long winter night, light from the upper atmosphere moves across the frozen lagoon. For those quiet moments, sky, mountain, water, and ice seem to move together. With the return of daylight, Iceland reveals every force that has shaped it: ocean, ice, wind, and fire. Few places on Earth contain so many opposing landscapes within such a small and isolated world. Beyond Iceland, an even greater frozen kingdom rises from the Northern Sea, where ice is always moving toward the ocean. Beyond Iceland rises Greenland, an immense frozen kingdom where mountains and ice meet the Arctic Ocean. At the center of this island lies one of the greatest bodies of ice remaining on Earth. Only the highest peaks escape the ice, standing above the frozen surface as silent islands of stone. Cold air descends from the interior with extraordinary force, carrying snow toward the distant coast. During the brief summer, sunlight awakens a network of rivers across the frozen surface. Some rivers vanish into openings that carry liquid water far beneath the ice sheet. Within these fractures, light reveals ice formed from snow that fell long before human memory. Drawn by gravity, the ice begins a long descent from Greenland's interior toward the ocean. At the coast, the frozen river meets salt water and begins to break apart. With a sound that echoes through the mountains, ancient ice begins a new life upon the sea. Freed from the glacier, each iceberg is carried into the fjord by tides, wind, and current. No two frozen giants are identical, for each is reshaped continuously by water and weather. The visible ice is only a small part of a structure that continues far beneath the waves. Below the waterline, melting currents carve smooth passages through ice hidden from the sky. For ringed seals, floating ice provides a place to rest above waters rich with food. Across the frozen surface, another traveler leaves signs of a solitary search for survival. The polar bear depends upon sea ice as a platform from which to explore the ocean. Patience is essential, for a single opportunity may require hours of silent waiting. Most hunts end without success, forcing the bear to continue its demanding journey. When the ice separates, powerful limbs carry the bear across the channels between frozen platforms. During summer, some bears reach land, where the search for food becomes even more difficult. Smaller predators survive here through speed, adaptability, and an ability to use every available opportunity.
The Arctic hare remains alert within a landscape where shelter is scarce and danger can arrive silently.
Among Greenland's most ancient survivors, musk oxen carry the appearance of another age. The calves are protected within the herd, surrounded by adults equipped to face the Arctic cold. During moments of rivalry, immense strength is tested in collisions that echo across the valley. For a few brief weeks, the tundra exchanges its winter silence for an explosion of color. Meltwater transforms the valleys into seasonal wetlands where migrating birds can feed and nest. Wild reindeer follow familiar routes between feeding grounds as the short Arctic summer advances. From the high ridges, Greenland reveals a landscape connected by ice,
rivers, mountains, and sea.
Along the coast, inaccessible cliffs provide sanctuary for enormous colonies of nesting birds.
Thick-billed mureys travel repeatedly between their crowded ledges and feeding grounds beneath the sea.
Puffins use the brief abundance of summer to raise their young within hidden coastal burrows.
High above the colonies, one of Greenland's largest birds surveys the coastline from the wind. The summer light reaches into the ocean, supporting microscopic life at the foundation of the marine food web. Small fish concentrate the ocean's energy and attract hunters from both water and sky. Each summer, humpback whales travel north to feed within Greenland's productive coastal waters. Working beneath the surface, the whales use bubbles to concentrate scattered fish into a smaller space. In a sudden burst of power, 40 tons of living muscle rises above the Arctic Sea. Farther north, narwhals follow seasonal openings through an environment that few other whales can enter. The male's extraordinary tusk is an elongated tooth filled with millions of sensory connections. Nearby, belugas use sound and close social bonds to navigate the shifting world beneath the ice. For seals, the underside of the ice offers both a ceiling and a hidden landscape of ridges and passages. Even in these cold waters, delicate drifting creatures fill the ocean with unexpected color. In Greenland's shallow fjords, underwater forests create shelter within an otherwise exposed coastline. In the cold depths lives one of Earth's longest-lived vertebrates, moving at a pace shaped by icy water. Far below the surface, slow-growing communities transform the dark seabed into a garden of living color. As summer ends, the ocean begins to freeze, rebuilding the platform upon which Arctic life depends. Each day becomes shorter, until the sun no longer rises above the northern horizon. Winter storms reduce the world to wind and white, challenging every creature that remains. After months beneath the snow, a mother introduces her cubs to the frozen world outside. Play strengthens young bodies and prepares the cubs for a life spent crossing ice and water. Every step becomes a lesson as the family begins its first journey toward the hunting grounds. Above the winter ice, charged particles create curtains of light across the polar sky. Even at the smallest scale, freezing water creates structures of extraordinary precision. After the long darkness, the returning sun begins another transformation of the Greenland coast. As warmth returns, the frozen surface fractures, and the ocean begins to move freely once again. Summer brings movement back to the coast, as animals gather around newly opened water.
Greenland is not an empty wilderness, but a living world shaped by the endless movement of ice.
Carried beyond Greenland's fjords, these frozen travelers begin a dangerous journey into warmer seas and toward the next great wilderness.
Driven south by wind and current, Greenland's ice enters a restless ocean between two immense northern worlds. Beneath every visible tower lies a much greater mass, hidden within the cold Atlantic water. Waves, salt, and changing temperature slowly weaken these frozen travelers from every direction.
Across the sea, the ancient coast of Labrador emerges from the mist, rugged and almost entirely untouched. Here, some of Earth's oldest rocks surround fjords, carved by the immense weight of vanished glaciers. Summer meltwater follows the paths left by ancient ice, carrying minerals from the mountains toward the sea. Weather changes without warning as ocean air collides with the steep walls of Labrador's northern mountains.
Across the high tundra, caribou travel through a landscape where food is widely scattered.
Young calves must quickly develop the strength required to follow the herd across rivers, valleys, and exposed ridges. During summer, new antlers grow rapidly, nourished by the brief abundance of the northern landscape. A patient hunter follows the migration, searching for weakness without wasting precious energy. Cooperation allows the pack to cross immense territories and survive where opportunities are uncertain. Farther south, sheltered valleys support richer vegetation and another powerful northern omnivore. Small fruits convert the long summer daylight into concentrated energy before winter returns. Along productive rivers, the search for food brings forest and freshwater ecosystems together.
After years at sea, Atlantic salmon return to the rivers where their lives began.
Every meter upstream demands strength as the fish resist a river determined to carry them back toward the ocean.
From the forest canopy, powerful eyes monitor the seasonal movement of fish through clear water.
Beyond the tundra begins the boreal forest, an immense northern world shaped by water, fire, and cold. Within these wetlands, the moose finds both food and protection among the shallow lakes. The calf remains close to its mother while learning the hidden roots connecting forest and water.
A smaller engineer transforms the landscape by slowing streams and creating new wetlands.
Beneath the surface, a concealed entrance provides safety from winter cold and many terrestrial predators.
Countless rivers drain the interior, cutting through stone that has endured for billions of years. At the coast, freshwater and ocean currents meet, carrying nutrients into a highly productive boundary. Each summer, capelins approach the coast in numbers great enough to transform the entire food web.
The fish move into the shallows, bringing the energy of the open ocean almost onto the land. From high above, gannets strike the water at extraordinary speed to reach the fish below.
Beneath the surface, thousands of fish respond together, creating a living shield of synchronized movement.
The gathering fish attract much larger travelers from the open North Atlantic.
Hunters from sea and sky converge upon the same abundance, each using a different strategy. With one powerful ascent, the whale gathers thousands of small fish within its expandable mouth. Fin whales cross these productive waters with speed and efficiency, following concentrations of fish and plankton. White-beaked dolphins bring speed and social cooperation to the cold waters of the Labrador Sea.
By coordinating their movements, the dolphins prevent the school from escaping into open water.
At the edge of the gathering, another intelligent hunter arrives from the deeper sea.
Orca families remain together across generations, sharing knowledge of currents, prey, and seasonal routes.
The youngest animals learn through constant observation, remaining close to experienced adults.
Even tropical-looking travelers reach these cold seas, drawn north by seasonal concentrations of jellyfish. Protected by a unique body adapted to retain heat, the leatherback can forage far beyond warmer waters. At the Labrador front, seasonal ice becomes a temporary nursery for thousands of harp seals.
Born upon unstable ice, the pup depends completely upon its mother during the first days of life.
The mother must repeatedly return to the sea, gathering energy from the rich waters below. Below the nursery lies an underwater feeding ground sustained by plankton and small fish. Within weeks, the pup must exchange the security of the ice for an independent life at sea. The nursery disappears almost as quickly as it formed, releasing a new generation into the North Atlantic. In the deep cold, an ancient shark continues a life that may span several human centuries.
The seafloor supports intricate communities whose slow rhythms remain hidden beneath the restless surface.
The Atlantic wolffish is built for crushing hard-shelled prey within the cold and rocky depths.
On the open bottom, camouflage allows the halibut to disappear within the patterns of sand and shadow.
Farther south, the cold current reaches Newfoundland and enriches a coastline of cliffs, islands, and hidden bays.
On isolated islands, Atlantic puffins gather in one of the ocean's most energetic summer colonies. Each journey from sea to burrow delivers the nourishment required during the chick's short season of growth. Nearby, gannets transform bare stone into a crowded city of wings, calls, and constant movement.
Within the crowded colony, ritual movements strengthen the bond between returning partners.
When ocean storms arrive, every exposed surface is tested by wind, rain, and breaking water.
The violence passes, leaving fresh water, mist, and renewed light across the battered coast. After sunset, microscopic plankton briefly transform each breaking wave into a line of living light. From frozen mountains to crowded ocean colonies, Labrador and Newfoundland are connected by the movement of water and life. Beyond the island, cold and warm currents collide above a vast underwater plateau, creating one of the richest seas in the North Atlantic. Above the Grand Banks, cold northern water meets warmer currents from the south, creating a sea concealed beneath almost permanent fog. Beneath the waves lies an enormous submerged plateau, shaped by ancient glaciers and enriched by moving currents. Deep scars across the bottom preserve the passage of icebergs that once grounded upon this shallow shelf. The Labrador Current carries cold water, oxygen, and nutrients from the Arctic into the Northwest Atlantic.
Where northern and southern waters meet, temperature boundaries concentrate nutrients and marine life. And
with the return of longer days, microscopic algae multiply and capture the energy of sunlight.
Tiny crustaceans graze upon the bloom, transferring its energy into the wider ocean food web. Small schooling fish gather wherever plankton becomes abundant, linking the microscopic world to powerful predators. Capelins survive through coordinated movement, using the entire school as a constantly changing shield. When danger approaches, herring compress into a living sphere that confuses individual hunters. Young cod spend their early years above the shelf, feeding among stones shaped by ancient ice. Fully grown Atlantic cod become powerful hunters, capable of crossing large areas of the continental shelf. Rather than pursuing the entire school, the cod search for isolated fish and brief moments of opportunity. A group of mature haddocks explore the sediment for worms, mollusks, and small crustaceans concealed below the surface. Camouflage allows flatfish to disappear into the shelf, leaving only their upward-facing eyes exposed. The halibut combines concealment with sudden speed, transforming a motionless silhouette into a powerful hunter. Across the open seabed, skates travel with movements that appear almost like flight.
The colder regions of the shelf support communities adapted to temperatures only slightly above freezing.
Within sheltering crevices, lobsters wait through daylight before beginning their search for food. Competition for secure shelter is settled through displays of strength that often end without serious injury.
Where moving water delivers suspended food, even the seafloor becomes crowded with feeding life. At the shelf break, slow-growing animals create fragile gardens within the cold darkness.
These living structures provide refuge for fish and invertebrates across generations.
Specialized teeth allow the wolffish to open armored prey that many other hunters cannot use.
During the long development of the eggs, the male remains nearby and protects the next generation. Squid exchange information through color, posture, and movement within the dim water above the shelf.
Jet propulsion gives squid the speed required to approach prey and escape larger hunters.
Warm currents carry open ocean predators northward toward the productive boundary of the shelf. The porbeagle is adapted to cold seas, maintaining powerful muscles as it searches for fast-moving fish.
A sudden burst of speed breaks the school apart, but most of the fish escape through synchronized movement.
Not every giant shark is a hunter of fish, for the basking shark survives by filtering microscopic prey. As water crosses the gills, tiny plankton are separated from the sea and gathered as food. Mackerel remain in constant motion, following seasonal bands of productive water across the North Atlantic.
Social hunters use cooperation to reduce the escape routes available to fast-moving fish. The movement below becomes visible from the sky, attracting birds capable of diving deep beneath the waves.
After journeys spanning entire hemispheres, shearwaters arrive to exploit the northern summer.
Beneath the waves, their wings become powerful paddles, transforming flying birds into agile underwater hunters.
Some of the smallest seabirds survive above the open Atlantic, feeding where wind and current gather life.
Even a melting iceberg becomes a temporary island within the open sea.
As the submerged base melts unevenly, the iceberg loses balance and suddenly turns within the sea.
Air sealed within the glacier long ago is finally released into the modern Atlantic. Minke whales move quietly through the shelf waters, following small fish along the edges of cold currents. With rapid changes of direction, the smallest baleen whale of these waters approaches concentrated prey. Humpbacks reshape the behavior of the school by building a rising barrier of bubbles. A synchronized ascent allows the whales to capture the concentrated fish within a single powerful movement.
Young whales learn the routes and feeding grounds that may guide them throughout their lives.
Through play and repetition, the calf develops the strength and coordination required for migration.
The Gulf Stream carries tropical warmth northward, forming one of the most powerful ocean currents on Earth. Along the current's edge, contrasting waters create a shifting frontier rich in oxygen, nutrients, and life.
Floating material gathers wherever surface currents converge, creating narrow pathways across the open sea.
Within every cup of seawater, a hidden community begins the transfer of energy through the food web.
Alps filter tiny particles from the water, transforming microscopic abundance into living tissue.
For young fish, drifting vegetation provides one of the few shelters available in an ocean without walls.
When pursued, flying fish escape the sea itself, using speed and enlarged fins to cross the air.
Mahi-mahi patrol the warm current with extraordinary speed, following prey across the sunlit surface layer. A moment of hesitation can decide the chase, allowing the escaping fish to vanish into the confusion. Fast-moving predators force small fish into coordinated formations that change shape with every attack. Internal heat allows the bluefin tuna to move between contrasting temperatures while maintaining exceptional strength. By approaching from below, the tuna use the bright surface to conceal their powerful silhouettes. The short-fin mako combines a streamlined body with warm muscles, making it one of the ocean's fastest sharks. The school survives by splitting at the final instant, forcing the hunter to choose between moving targets.
Built for distance rather than sudden acceleration, the blue shark crosses entire ocean basins with remarkable efficiency. Subtle changes in temperature guide wandering predators toward temporary concentrations of prey.
As daylight weakens, the swordfish ascends from colder depths to hunt within the upper ocean. Large eyes and specialized heat-producing tissues help the swordfish pursue prey in cold, shadowed water. Each evening, squid join one of Earth's greatest migrations, rising from darkness to feed near the surface. Countless lanternfish carry deep ocean energy upward, feeding predators that patrol the surface after dark.
Common dolphins travel in highly social groups, using speed and cooperation to search the current at night.
Experienced hunters shape the moving school as younger dolphins learn by following every coordinated turn.
Farther into subtropical water, Atlantic spotted dolphins join the moving community of the Gulf Stream. But the calf remains within the protection of the pod, while developing the speed required for life in open water.
Pilot whales pause between dives above slopes, where squid gather hundreds of meters below. Together, the pod enters darkness, relying upon sound to navigate and locate moving prey.
Among the most extreme diving mammals, the beaked whale spends only brief intervals visible at the surface.
Its journey continues far below sunlight into a pressurized world inhabited by squid and deep-water fish. The ocean sunfish occasionally rests at the surface, where seabirds may remove parasites from its body. Its unusual shape conceals an efficient swimmer capable of making repeated journeys into deeper, colder layers. Floating sargassum becomes a traveling habitat for young turtles crossing the western Atlantic. Many inhabitants match the weeds so precisely that color becomes their first defense against discovery. The sargassum fish transforms stillness and camouflage into a hunting strategy within the floating forest.
Even at close range, success depends upon patience and a final movement timed with precision.
The floating canopy provides shade, food, and temporary protection during the turtle's vulnerable oceanic years. Rather than wandering without direction, young turtles use currents as highways connecting distant regions.
Driven by wind and current, this colonial animal crosses the surface beneath a delicate living sail.
A fragile raft of mucus and air allows the violet snail to live suspended beneath the ocean surface.
The blue sea dragon uses color and orientation to become nearly invisible between sea and sky.
Within the floating forest, changing patterns allow the filefish to disappear against a constantly moving background. Any structure in the open ocean attracts young fish seeking protection from predators approaching below. Larger hunters inspect the floating habitat, turning a place of shelter into a place of danger. The sailfish uses speed, maneuverability, and sudden changes of direction to control a schooling prey. By attacking in sequence, the hunters maintain pressure without exhausting themselves all at once.
The school survives by changing shape faster than any single hunter can anticipate.
The hammerhead's expanded head carries sensory organs across a wider area, helping it detect life hidden below.
Under favorable conditions, normally wandering hammerheads gather around isolated features in the open ocean.
The submerged mountain interrupts deep currents, concentrating food around its exposed slopes.
Where hard stone rises into moving water, corals create shelter for communities far from any continent.
Life gathers on the current-facing slope, where moving water continuously delivers suspended food. In colder depths, slow-growing animals construct fragile habitats that may endure for centuries.
Ancient six-gill sharks patrol the lower slopes, conserving energy within cold and nearly lightless water.
Far beneath the current, delicate animals survive upon fragments of energy sinking from the world above. In permanent darkness, extreme adaptations allow small predators to survive long intervals between meals. From the deep seabed to the floating forest, the Gulf Stream connects habitats separated by thousands of meters.
Along the western Atlantic, one of the world's rarest great whales guides a new calf through coastal waters.
The calf remains close, depending upon its mother for nourishment, protection, and knowledge of the migration route. Migrating whales use the current system as part of an oceanic pathway connecting northern feeding grounds with tropical waters. Every traveler encounters the Gulf Stream differently, yet all are influenced by its warmth, speed, and direction. Beyond the racing current lies a quieter ocean, encircled by moving water, the mysterious Sargasso Sea.
Surrounded entirely by powerful currents, the Sargasso Sea is an ocean within an ocean. Here, circling currents gather drifting life across an area larger than many nations.
Unlike rooted seaweeds, sargassum spends its entire existence floating freely within the open Atlantic.
Tiny natural floats lift every branch toward the light required for continued growth.
Within this floating canopy, shade, shelter, and food transform empty water into a living habitat.
Color provides concealment for animals that have evolved to resemble their drifting home.
Specialized limbs allow the crab to crawl, swim, and remain close to the floating vegetation. Even the surface of a single branch supports communities almost invisible to the human eye. The pipefish survives through imitation, becoming another slender branch within the floating forest.
Across the Sargasso Sea, evolution repeatedly favors the colors and shapes of the habitat itself.
Few residents are more difficult to recognize than the sargassum fish, a predator disguised as floating weed. A delicate lure attracts curious prey within range of an exceptionally rapid strike. In this crowded maze, even the smallest animal may find a hidden route to safety. Young filefish adjust their appearance to match a background that changes with every passing wave. For young fish born far from reefs, the floating canopy becomes a temporary nursery. Growing hunters also use the drifting habitat, learning to search its shadows for opportunity. Before it can glide above the waves, the young flying fish depends upon concealment beneath floating weed. Every movement from above may signal danger in a habitat offering only fragile protection. After entering the Atlantic, young loggerheads may spend years traveling within this drifting ecosystem. The weed provides rest, camouflage, and a continual supply of small prey for the growing turtle.
Different turtle species share these oceanic nurseries during the most vulnerable years of their lives.
Young turtles feed opportunistically, taking both plant and animal life encountered along their journey. Each drifting raft differs in age and complexity, carrying its own temporary community. Separated by great distances, these young travelers are connected by the same slow-turning current system. Fast-moving fish pass regularly beneath the floating forest, linking its sheltered community with the surrounding ocean. Mahi-mahi search every boundary where small fish gather between shelter and open water. The tangled canopy breaks the hunter's line of pursuit and gives smaller fish a final refuge. Built for explosive speed, the wahoo approaches from open water and disappears almost as quickly as it arrived. Large billfish cross the Sargasso Sea while following prey through warm, transparent water. The school survives by separating at the final moment, leaving the hunter surrounded by empty water.
After years in fresh water, mature eels enter the Atlantic and travel toward their ancestral spawning region.
Guided by inherited instincts and changing ocean conditions, they cross distances no individual has traveled before. European eels also journey toward the western Atlantic, connecting distant rivers with this remote sea. By moving deeper during the day, migrating eels may reduce their exposure to predators near the surface. Darkness allows the journey to continue through shallower water, beneath the protective cover of night. From this region, transparent eel larvae begin a new journey, carried outward by Atlantic currents.
Its flattened, transparent body offers concealment and reduces the energy required to remain suspended. The same current system carries a new generation toward rivers separated by an entire ocean. For months, the fragile larvae remain part of the plankton, growing as the Atlantic transports them. The life cycle of the eel reveals how distant rivers and the open ocean remain inseparably connected.
Below the visible canopy, transparent drifters process the limited food suspended within this nutrient-poor sea. The colors of comb jellies are created not by light of their own, but by sunlight divided across tiny structures.
Beneath a gas-filled sail, an entire colony travels wherever wind and surface current carry it.
Unable to swim strongly, violet snails construct floating rafts that suspend them at the boundary between air and sea. Reversed coloration conceals the blue sea dragon from predators looking from either above or below. Every evening, deep-water animals ascend toward food concentrated within the upper ocean. Among the most numerous vertebrates on Earth, bristlemouths remain almost entirely hidden within darkness. Reflective scales and downward-facing lights reduce the silhouette of the hatchetfish within the twilight zone. Specialized red light allows this predator to illuminate prey that cannot detect the same wavelength.
In open darkness, a sudden cloud of ink creates only seconds in which to escape.
Above the deep Sargasso Basin, beaked whales prepare for some of the longest dives made by any mammal.
Within minutes, the whale leaves sunlight behind and enters a world known primarily through sound. Sperm whale families cross this quiet sea above depths inhabited by squid and deep-water fish. A powerful tail carries the whale downward through more than 1,000 meters of darkening water.
Hunter and prey share an immense darkness, in which most encounters remain unseen.
The floating forest is continually reshaped by wind, waves, and the circulation surrounding it. Young animals descend beneath the most turbulent water, using the drifting mass as shelter during the storm. When calm returns, the forest separates and begins forming new communities across the open sea.
From drifting larvae to deep-diving whales, the Sargasso Sea shelters life across every layer of the ocean. Beyond the floating forest, an ancient summit rises from the abyss, gathering life around the remote waters of Bermuda. In the center of the western Atlantic, an ancient volcanic summit rises high enough to support an island and a living reef.
Warm currents surround a shallow platform perched above thousands of meters of open ocean.
The remains of an ancient volcano form the foundation beneath layers of reef-built limestone.
Along the exposed rim, corals endure waves that continually reshape the boundary between reef and ocean. Rain corals grow slowly, adding thin layers of living structure through countless changing seasons. Every great colony is constructed by thousands of small animals, sharing a single limestone foundation. Where the reef rises toward sunlight, branching communities of fish gather above its strongest coral structures. The school feeds above the coral but returns to shelter at the first suggestion of danger. Bold markings help these social reef fish recognize one another within the constantly moving crowd. Butterfly fish travel in close partnerships while searching the reef for tiny, hidden sources of food.
Sponges provide essential food for angelfish, able to process tissues avoided by many other animals.
Grazing fish limit the growth of algae that might otherwise occupy open surfaces needed by young corals. Parrotfish transform fragments of limestone into sand while opening new space across the reef. Over time, countless small fragments produced by reef life accumulate to create Bermuda's pale underwater sands. Bermuda chubs remain close to the upper reef, feeding where waves deliver drifting material. Near the boundary between sea and air, specialized fish search for plankton carried across the reef. Fast pelagic visitors connect the sheltered reef with the immense ocean surrounding the platform. The reef offers refuge, but every entrance is watched by hunters capable of exploiting a moment of confusion.
By moving as one reflective mass, the smaller fish make a single target difficult to follow.
The barracuda conserves energy through stillness, waiting until distance and direction favor sudden acceleration.
By imitating the reef's upright forms, the trumpetfish approaches without revealing the outline of a hunter.
Rocky chambers provide powerful groupers with shelter, from which they can observe the surrounding reef. At cleaning stations, temporary cooperation allows small fish to feed, while larger visitors lose irritating parasites.
The moray's repeated mouth movements pump water across its gills and do not necessarily signal aggression.
And long antennae advertise another cleaning station hidden within the reef's narrow passages. When daylight fades, spiny lobsters leave their shelters and begin searching across the reef. Color, texture, and posture change together, allowing the octopus to match several backgrounds within seconds. A carefully selected shelter offers protection during the bright hours and concealment from larger predators. Changing skin patterns allow reef squid to communicate while remaining responsive to the surrounding light. Large eyes prepare squirrelfish for a nocturnal world that begins as other reef inhabitants seek shelter. Night reveals a hidden community that spends the day compressed within cracks and limestone chambers. After sunset, coral colonies become active hunters, collecting plankton from the water passing overhead.
The smallest drifting animals support a food web extending from coral polyps to great ocean travelers.
Broad fins carry the eagle ray above the bottom, with movements resembling flight through water.
Sensitive organs help the ray detect hidden prey, even when no movement is visible at the surface. Shallow seagrass meadows provide feeding grounds for turtles returning from journeys across the open Atlantic. Regular grazing keeps parts of the meadow young and transfers energy from plants into the wider ecosystem. For young reef fish, dense vegetation becomes a nursery filled with narrow routes unavailable to larger hunters.
The jawfish rarely travels far from the shelter it has carefully excavated within the sand.
When open water offers no refuge,
the razorfish escapes by vanishing beneath the seafloor.
By disturbing the bottom, the hogfish exposes tiny animals and creates opportunities for smaller companions.
Rainwater and changing sea levels carved an underground landscape through Bermuda's porous limestone.
The cave entrance offers shade and shelter while remaining connected to the food carried by the open sea.
Within the darkness, specialized communities occupy surfaces rarely touched by direct sunlight. Hidden passages connect inland pools with the ocean, allowing tides to move silently beneath the island.
In isolated coastal wetlands, small native fish tolerate rapid changes in salinity and temperature.
Mangrove roots slow the water and create protected spaces between the island and the surrounding sea.
On land, one of Bermuda's rare native reptiles survives within fragmented pockets of natural shoreline.
Known locally as the longtail, this ocean bird returns to Bermuda's cliffs after months spent above the open sea.
Paired birds use aerial displays to renew bonds before returning toward protected nesting crevices. The Bermuda petrel, once believed lost, now returns from the Atlantic darkness to isolated nesting islands.
Outside the platform, flying fish escape underwater hunters by entering an entirely different world for several seconds.
Dolphins patrol the steep boundary, moving between productive shallows and prey rising from deeper water. Coordinated movement allows the pod to investigate a three-dimensional hunting ground extending down the volcanic slope. During their northern migration, humpback families pass Bermuda on the long journey toward rich feeding grounds. Every controlled dive strengthens the young whale for the colder and more demanding ocean ahead. Beyond the reef edge, pilot whales gather above depths where squid rise and fall through the water column. Deeper communities survive with limited light, extending the reef far beyond the range visible from the surface. From flooded caves to the open Atlantic, Bermuda concentrates extraordinary life upon a solitary summit surrounded by the abyss. Beyond Bermuda, the current carries another great traveler toward a world of luminous shallows, the vast banks of the Bahamas. Across the Bahamas, shallow carbonate banks transform the western Atlantic into a luminous world of sand and warm water.
Tides carve temporary pathways across a platform built from the accumulated remains of marine life.
On the open bank, the tiger shark patrols patiently, using pattern and stillness to approach without attracting attention. A buried ray senses the approaching hunter and leaves the bottom before the distance becomes dangerous. Where tides expose hidden animals beneath the sand, stingrays arrive to search with sensitive mouths and electroreceptors.
A covering of sand conceals the ray, while water enters through openings positioned safely above its buried body.
Spotted eagle rays travel across the banks in search of mollusks hidden beneath the shifting surface. Powerful jaws can crush hard shells, allowing the ray to reach food unavailable to many other hunters.
What appears empty from above contains a hidden community adapted to life beneath an unstable seafloor.
Garden eels remain anchored within their burrows, collecting drifting food without fully exposing their bodies. The queen conch crosses the bank in deliberate steps, grazing upon algae growing across sand and vegetation. These temporary paths record the quiet movement of animals traveling between open sand and protected feeding grounds. Seagrass roots stabilize the shallow sediment, while their leaves convert intense tropical sunlight into living tissue.
Green turtles return repeatedly to productive meadows, cropping the youngest and most nutritious blades.
The shallow bank offers young turtles both food and space to rest between journeys through deeper water. Even animals perfectly shaped for the ocean must regularly cross the boundary between water and air. Every blade supports smaller life, transforming the meadow into a nursery extending across several layers.
By consuming and redistributing sediment, sea cucumbers recycle nutrients through the shallow ecosystem.
Slow-moving sea stars search the bottom while becoming miniature habitats for even smaller organisms. Unlike sharks that must swim continuously, the nurse shark can pump water across its gills while resting. Tides connect the open bank with mangrove forests, carrying oxygen, nutrients, and young animals deep into sheltered channels. The narrow spaces between roots exclude larger hunters and provide young fish with a temporary refuge.
Young lemon sharks remain in shallow nurseries, where familiar channels provide food and protection from larger predators.
The shark learns to hunt within a maze where every root changes the direction of pursuit. At the channel entrance, a patient hunter watches the current concentrate animals leaving the mangrove forest. The school responds instantly, turning confusion into a coordinated wall of silver.
Bonefish enter water too shallow for many large predators, using speed and camouflage to search across the tide.
The sensitive mouths locate crustaceans beneath the sediment, leaving temporary marks erased by the returning tide.
These jellyfish invert the familiar form, exposing symbiotic algae within their tissues to the tropical sun.
Above and below the surface, a single network of roots supports animals from two different worlds. Beneath the bright bank, ancient flooded caverns open into depths where sunlight rapidly disappears. Changing sea levels flooded caves carved during earlier periods when the platform stood above the ocean. Layers of water with different salinity bend light and create a wavering boundary within the cave. Specialized animals survive within this isolated environment by using the limited food carried through hidden connections.
Near the entrance, schooling fish remain close to daylight, while using the deep chamber as immediate shelter.
The hunter enters from darkness, yet thousands of simultaneous movements make one fish almost impossible to isolate. In a few protected shallows, microbial communities still construct layered structures resembling some of Earth's most ancient ecosystems. Microscopic organisms bind sediment one layer at a time, slowly transforming loose particles into enduring structure. With each tide, the ancient builders become part of a modern coastal food web. At the edge of the platform, the shallow bank meets an oceanic wall shaped by waves, currents, and living coral. Elkhorn coral creates strong branching barriers that reduce wave energy and provide shelter for countless small fish.
Within the finer branches of staghorn coral, young animals find spaces inaccessible to larger hunters.
As daylight fades, thousands of coral animals extend their tentacles and begin collecting food from passing water. Grunts gather in protected reef shelters by day before dispersing across nearby feeding grounds after sunset. The Nassau grouper is a powerful reef predator, yet much of its success depends upon patience and careful positioning. At a cleaning station, normal hunting behavior is temporarily suspended for an exchange benefiting animals of very different sizes. Beyond the coral crest, reef sharks patrol routes shaped by currents and the daily movement of schooling fish. The reef continues downward beyond the bright shallows, creating hunting space across an immense vertical boundary. The hammerhead's expanded head places sensory organs across a wider field, helping it detect animals concealed below.
The ray abandons concealment at the final moment and uses rapid acceleration to reach complex cover.
Far from the shallow banks, the oceanic whitetip is adapted to travel through an environment offering almost no fixed shelter. Small companions use the moving shark as protection while searching for scattered feeding opportunities.
The shark relies upon endurance, but fast tuna can escape through sudden changes in speed and direction.
Between the shallow platforms, a deep oceanic canyon cuts thousands of meters into the Bahamian seafloor. As night approaches, deep-water animals ascend toward the productive surface in one of Earth's greatest daily migrations. Beaked whales use these deep channels to reach squid and fish hidden far below the reach of sunlight. During the descent, the whale conserves oxygen for the demanding search that will begin at depth.
Spotted dolphins move easily between the shallow bank and deep channels, maintaining complex social bonds throughout their travels.
Across the Bahamas, brilliant shallows and hidden depths combine to create one of the Atlantic's most diverse ocean landscapes. South of the Great Banks, Atlantic water enters a warmer sea where deep trenches, coral islands, and powerful currents shape the wild Caribbean. Through this narrow gateway, Atlantic water enters the Caribbean and begins a long westward journey. Beneath the surface, deep channels separate island slopes shaped by ancient volcanic and tectonic forces. Where currents converge, traveling predators encounter schools concentrated along invisible boundaries in the sea. Built for continuous motion, blackfin tuna cross the passage with speed few reef inhabitants can match. When danger approaches from below, flying fish escape by briefly transforming the air into a second habitat. Drifting seaweed becomes a mobile island, carrying shelter and food across otherwise featureless water. For young ocean animals, this tangled canopy provides temporary protection during the most vulnerable stage of life. Along Cuba's southern coast, remote reefs form one of the Caribbean's richest natural strongholds. Strong branching colonies absorb the energy of incoming waves while creating shelter for smaller reef residents. Flexible corals orient themselves toward the current, collecting microscopic food without resisting the water's full force. The queen angelfish searches complex reef surfaces for sponges and other small organisms hidden among the coral. Parrotfish control fast-growing algae and gradually transform fragments of reef limestone into pale tropical sand. The hawksbill's narrow beak reaches into spaces inaccessible to broader-mouthed reef animals. A powerful grouper needs little movement while watching every route through its familiar territory. At this cleaning station, a temporary truce allows tiny fish to remove parasites from a potential predator. The reef shark patrols wide territories, connecting separate coral ridges through its daily movements. A coordinated school changes shape faster than the hunter can isolate a single individual. Between reef and forest, tarpon use deep coastal channels as sheltered routes through the island ecosystem. Thousands of small fish shelter together, responding to every movement with almost simultaneous precision. Stillness and camouflage allow the barracuda to observe the channel without announcing the presence of a hunter.
Within this living maze, young reef fish grow beyond the reach of many larger predators.
Able to tolerate salt water, the American crocodile travels between coastal lagoons, mangroves, and sheltered bays. By facing upward, these jellyfish expose symbiotic algae within their tissues to the energy of tropical sunlight.
Young barracuda begin life within sheltered coastal habitats before moving toward the exposed reef.
Spiny lobsters sometimes follow one another across exposed ground, reducing the danger of traveling alone.
Color, skin texture, and body posture change together as the octopus moves across contrasting surfaces.
Rapid changes across the skin allow squid to communicate without producing a sound.
For only a brief period, many corals release their reproductive cells together, increasing the possibility of new colonies. This annual event transfers an immense pulse of energy from the reef into the surrounding food web. The largest fish in the sea survives by collecting some of the smallest animals carried through tropical water.
Farther west, steep island slopes descend rapidly into water thousands of meters deep.
Along the island's edge, coral communities occupy narrow terraces above an immense underwater slope. Plankton carried along the wall supports great schools of fish that feed while remaining in constant motion. Different species occupy separate layers above the reef, each responding to current and danger in its own way. The slender hunter uses surrounding shapes and even larger fish to conceal its approach. Within the narrow chamber, a small cleaner gains food while the moray loses irritating parasites. Broad fins generate graceful movement as the rays cross from coral terraces into open water.
The male protects the next generation within his mouth, briefly releasing and turning the eggs to keep them oxygenated.
Pigment cells alter the flounder's appearance, reducing the contrast between its flattened body and the seafloor. Rather than pursuing food at speed, the seahorse waits for small drifting animals to pass within reach. Here, tectonic forces created the Caribbean's deepest frontier, separating sunlit islands with an oceanic abyss.
Sperm whale families gather at the surface before adults descend into the darkness to search for squid.
A raised tail marks the beginning of a dive that may carry the whale far beyond the reach of sunlight.
The whale crosses the planet's greatest daily migration as countless small animals ascend from deeper water.
Swordfish follow migrating prey through a vertical world that changes with every cycle of daylight.
Light-producing organs help some squid communicate and control their visibility within the twilight zone. The Cayman Islands rise directly from deep water, allowing reef communities to develop beside the open ocean. Turtles use ledges along the wall as temporary resting places between feeding journeys across shallower habitats. Sensitive organs guide the rays toward movements hidden beneath a surface that appears completely empty. Each eel remains anchored beneath the sand, retreating instantly when a shadow approaches.
The grouper's presence changes the movement of smaller fish, even when the predator makes no attempt to hunt.
Each shark patrols the vertical reef independently, guided by currents, scent, and the movement of potential prey.
Beyond the strongest sunlight, specialized communities extend the living reef down the island's steep slope. In the dim water, every projecting structure creates valuable shelter above the exposed rock. Hidden by day, the basket star expands an intricate living net to collect particles carried through the night. Minute crustaceans communicate through precise flashes, creating signals that last only moments in the Caribbean darkness. At the bottom of the trench, seawater heated within fractured rock returns carrying dissolved minerals from beneath Earth's crust.
Without sunlight, specialized shrimp depend upon microbial production supported by chemicals released from the seafloor.
From the deepest vents to the brightest surface, moving water connects distant habitats across the Caribbean basin. Ahead lies the Mesoamerican Reef, a living corridor where coral forests, coastal nurseries, and great ocean travelers meet. Along the coast of Belize, a vast living barrier separates sheltered nurseries from the power of the open Caribbean. At the reef's exposed edge, branching corals weaken incoming waves and create protected spaces for smaller animals.
Large parrotfish keep algae from overwhelming the reef, while gradually producing the sand surrounding tropical islands.
The queen conch crosses the lagoon with deliberate movements, feeding upon algae growing across the shallow bottom.
Between coral and coast, seagrass converts sunlight into food and provides a nursery for the next generation of reef fish. Within calm coastal water, the manatee depends upon extensive meadows that offer both food and protection from strong waves. A brief breath is followed by another unhurried descent into the sheltered world beneath the surface. The tangled roots form a living nursery where young fish can grow beyond the reach of many larger hunters. Young sharks learn every channel within the nursery, using warm, shallow water as both hunting ground and refuge. Within this maze, survival often depends upon turning through spaces the pursuing shark cannot enter.
Far from the mainland, Turnef Atoll encloses an intricate network of reefs, channels, forests, and shallow lagoons.
Each coral patch becomes a small island of life, surrounded by an open plain of shifting sand.
Moving with effortless strokes, eagle rays travel between feeding grounds scattered across the protected lagoon.
Permit you speed, alertness, and reflective camouflage while crossing exposed tropical shallows. Sensitive mouths locate small crustaceans beneath the lagoon floor, leaving trails erased by the next tide.
Able to tolerate salt water, the American crocodile travels between forest channels, coastal lagoons, and offshore islands.
Inside the dark channel, countless small fish combine into a shifting wall that confuses every approaching hunter.
The attack lasts only seconds, yet the school responds as though thousands of bodies share a single awareness.
Patterns produced by specialized pigment cells allow the squid to communicate through rapid visual signals.
After darkness, the lobsters leave their shelters and travel together toward productive feeding grounds.
Color, texture, and posture transform together, allowing the octopus to disappear across several different surfaces. Within Lighthouse Reef, an ancient limestone cavern opens beneath the sea as one of the Caribbean's most striking geological formations. Rising seas flooded the cavern, preserving evidence of an earlier age when this limestone stood above the ocean. Reef sharks occasionally cross the open chamber, using the blue hole as part of a much larger ocean territory.
The nurse shark can pump water across its gills, allowing it to remain motionless while resting on the bottom.
Circulation weakens with depth, creating layered water where oxygen becomes increasingly limited.
Only a short distance above the dark chamber, sunlight supports an entirely different world of coral and color.
Above the reef, isolated islands provide nesting habitat for seabirds that feed across the surrounding Caribbean. Using rising tropical air, frigate birds remain aloft with barely a wing beat while watching the ocean below.
The hawksbill moves between island shallows and coral slopes, using its narrow beak to reach food hidden inside the reef.
The outer slope receives a continuous supply of oxygen and plankton from the open Caribbean.
Seasonal movements bring normally solitary groupers together at traditional spawning grounds along the reef edge.
A precisely timed ascent releases the next generation into currents capable of carrying it across distant reefs. For only a few nights, large schools concentrate here and transfer an immense pulse of life into the open sea. Chemical signals and changing currents may guide a distant traveler toward this temporary abundance.
Despite its enormous size, the whale shark feeds by separating microscopic food from thousands of liters of seawater.
Smaller companions gain transport and protection by traveling beside one of the ocean's largest animals. Different travelers exploit the same brief event, each using a feeding strategy shaped by speed and body size. At the boundary between reef and open water, every seasonal gathering attracts hunters as well as filter feeders. Social hunters investigate the concentration of fish while remaining connected through coordinated movement.
The reef absorbs the force of the open sea, creating a sheltered environment behind its living barrier.
And tropical storms periodically transform this peaceful coast, testing every organism attached to the shallow reef.
When the water settles, survivors return, and the slow process of recovery begins across the reef. At a cleaning station, the normal relationship between predator and prey is briefly replaced by cooperation. Nocturnal grazers clear algae from hard surfaces, creating space where young corals may establish themselves. By feeding selectively upon sponges, the hawksbill influences competition for space across the crowded reef. When daylight fades, the reef's foundation changes from a rigid landscape into a community of active animals. Animals concealed throughout the day expand into the current and collect food carried through the darkness. Minute crustaceans transform chemical energy into precisely timed flashes used to communicate in the night. Moving water links Belize with reefs farther south, carrying nutrients, larvae, and ocean travelers across national boundaries. Off the coast of Honduras, island summits emerge from deep water along the southern edge of the Mesoamerican reef. Here, coral communities descend along steep island slopes, only a short distance from the open Caribbean. Where currents lift nutrients toward the surface, seasonal abundance can attract giant filter feeders from across the Caribbean.
Travelers of very different sizes share the same productive boundary before continuing along separate routes.
Beyond the Bay Islands, moving water guides the journey north toward coral channels, flooded caverns, and the wild coast of the Yucatan.
Following the Mesoamerican reef northward, ocean travelers reach one of the Caribbean's largest and most isolated coral atolls.
This vast coral ring rises from deep water, creating a protected interior surrounded by the force of the open Caribbean.
Branching corals weaken the incoming waves while providing shelter within one of the reef's most energetic environments.
Able to pump water across its gills, the nurse shark can rest without continuously swimming through the current. Along the exposed wall, sharks follow currents that concentrate scents, plankton, and the movements of reef fish. Every bite controls algae and gradually transforms ancient reef limestone into the pale sand surrounding the atoll. Across the sheltered bottom, queen conches feed on thin layers of algae while remaining almost invisible from a distance.
Eagle rays travel between feeding grounds, using sensitive organs to detect buried animals beneath the lagoon floor.
Far from the mainland, salt-tolerant crocodiles occupy isolated islands surrounded by coral reefs and open sea. Normally solitary adults assemble at traditional locations when seasonal currents and lunar cycles become favorable. A brief synchronized ascent allows the current to carry a new generation beyond the boundaries of the atoll.
Beyond the atoll lies Sian Ka'an, a natural mosaic connecting inland forests with mangroves, seagrass, and the Caribbean Sea.
Water moves through every part of this landscape, carrying nutrients from the forest toward the shallow coastal sea. Within sheltered water, the manatee depends upon productive meadows that grow between freshwater wetlands and the reef. Only the nostrils break the surface before the animal returns to its unhurried journey beneath the lagoon.
Warm nursery channels allow young sharks to develop their hunting skills while remaining separated from larger ocean predators.
The shark possesses speed, yet the smaller fish survive by turning through spaces its wider body cannot follow. By moving together, the silversides create a shifting barrier that makes one small target difficult to isolate. A perfectly timed escape transforms thousands of vulnerable fish into a coordinated defense. Crocodiles, fish, and coastal birds share a wetland shaped by the daily exchange of fresh and salt water.
The meadow provides food for large grazers and shelter for young animals preparing to enter the exposed reef.
Coastal nurseries connect directly with the reef, allowing animals to move between shelter, feeding grounds, and open ocean. The hawksbill's narrow beak reaches food inaccessible to many other animals within the crowded coral framework.
Farther north, Cozumel rises beside a channel where Caribbean water accelerates along steep coral slopes.
A constant flow of clear ocean water supplies oxygen and plankton to communities growing along the island's vertical edge.
Different fish occupy separate layers of moving water, balancing access to food against exposure to predators. Found naturally around Cozumel, The splendid toadfish spends much of its life hidden within dark reef chambers.
At a cleaning station, a powerful predator remains still while tiny fish remove parasites from its skin. Broad fins allow the rays to use moving water efficiently while crossing great distances along the island's edge.
The shark searches for weakness, but coordinated movement prevents it from easily separating a single fish.
Rapid changes in direction deny the hunter the isolated target required for a successful pursuit. Protected by darkness, the lobsters leave their shelters and follow one another toward open feeding grounds. Minute crustaceans use chemical light to produce signals that remain visible for only a fraction of the tropical night. Beneath the Yucatan Peninsula, rainfall travels through porous limestone before returning to the Caribbean through hidden springs. Where limestone ceilings collapse, openings reveal a vast underground world shaped by water over thousands of years. Roots penetrate the flooded chamber, creating a direct connection between the living forest and the water hidden below.
Within the coastal aquifer, fresh water floats above seawater, forming a shifting boundary known as a halocline.
These formations developed when the cavern contained air, preserving evidence of a landscape from the last ice age. Animals adapted to permanent darkness survive with reduced pigmentation, slow movement, and exceptional sensitivity to waterborne signals. Where organic material decomposes without sufficient oxygen, chemical layers can develop within the isolated depths. For a few hours each day, direct sunlight reaches the chamber and reveals water otherwise concealed beneath the forest. Above the flooded passage, bats occupy the remaining air-filled spaces and transfer nutrients from the forest into the cave. Although the underground river appears motionless, a slow current connects inland rainfall with mangroves and the Caribbean Sea. Fresh groundwater finally returns to daylight, altering salinity and delivering dissolved nutrients into the coastal nursery. Changes in temperature and salinity create a specialized refuge for young fish along the northern Yucatan coast. Beyond the mangroves, shallow lagoons provide feeding grounds for birds moving between the Caribbean and the Gulf of Mexico. Between Mexico and Cuba, powerful currents carry warm Caribbean water toward the Gulf while lifting food toward the surface.
During the warm season, temporary concentrations of food attract many solitary giants into the same productive water.
By holding its body upright, the giant can remain beneath a dense concentration and filter continuously.
Remoras gain transport and protection, while the whale shark continues its slow passage through the seasonal abundance. Manta rays use wide cephalic fins to guide plankton-rich water toward their mouths while conserving energy within the current.
Repeated rotations allow the mantas to remain within the richest part of a drifting cloud of food. Speed-driven hunters exploit the same productive current, using a strategy entirely different from the gentle giants above. Social travelers pass through the gathering, connected by coordinated movement across a vast and constantly changing seascape. As the season changes, different currents and prey transform the same region into a high-speed hunting ground.
Sailfish use speed, coordination, and sudden changes of direction to separate small groups from the larger school.
A fraction of a second determines the outcome, and this time the school separates before the hunter can isolate its target. At the edge of the Caribbean, this immense river within the sea enters a new basin of coral banks, deep canyons, and open ocean migrations.
After passing through the Yucatan Channel, Caribbean water becomes the loop current, one of the Gulf's most powerful moving systems.
Far from the mainland, Alacrane's Reef forms the largest coral structure within the southern Gulf of Mexico. Along the exposed crest, branching corals weaken incoming waves and create shelter within a constantly moving environment. Inside the reef ring, calmer water supports a complex community built upon generations of living coral.
The hawksbill reaches into spaces inaccessible to most animals, influencing the competition between sponges and corals.
Sensitive organs beneath the rays' heads detect buried prey, hidden below the apparently empty lagoon floor.
Stillness conceals the barracuda's intentions until a sudden burst of speed can be directed toward an isolated target.
The school survives by reacting as one, denying the hunter the separation required for a successful strike.
These large marine snails graze upon algae and organic material spread across the sheltered bottom.
Seagrass meadows feed large grazers, while functioning as nurseries for fish that will later enter the coral reef. Remote islands provide nesting ground for seabirds that travel far beyond the reef in search of food. Long wings and a deeply forked tail allow frigate birds to remain airborne while using remarkably little energy. Seasonal signals draw normally solitary groupers toward traditional gathering sites along the edge of the reef. A synchronized ascent releases the next generation into currents capable of carrying it across the Campeche bank. The reef is not isolated. Moving water carries its descendants toward distant habitats throughout the southern Gulf.
Beneath these shallow waters lies an immense limestone platform, supporting many different forms of marine life.
Seasonal travelers cross the open shelf together, gaining protection through numbers and coordinated movement.
Shallow nursery water separates young sharks from larger predators, while providing abundant opportunities to practice hunting.
Speed alone is insufficient when smaller prey can disappear into habitat too confined for the hunter to follow.
Color, skin texture, and posture transform together, allowing the octopus to match each surface along its path. Protected by night, the lobsters leave their shelters and travel together toward productive feeding grounds.
Specialized pigment cells create a rapidly changing visual language used during courtship, warning, and social recognition.
After sunset, the reef's foundation becomes active as individual coral animals begin capturing drifting food.
At the shelf edge, a sunlit limestone platform gives way to one of the Gulf's greatest changes in depth.
Where deep water rises along the margin, nutrients stimulate temporary concentrations of life near the surface. Wide cephalic fins guide food toward the mouth as the mantas remain inside the most productive layer. Repeated rotations allow these rays to pass through the same dense patch without abandoning the current. Each year, great bluefin tuna enter the Gulf to reproduce within warm water carried by the loop current.
Millions of buoyant eggs enter the surface layers, though only a small fraction will survive the drifting journey.
At this stage, one of the ocean's fastest predators is nearly invisible and entirely dependent upon microscopic food. Far from land, drifting seaweed creates a mobile habitat within otherwise featureless open water. Young turtles depend upon these drifting communities for shelter, food, and transport across the Gulf. Shape, color, and motion concede a small predator within the floating forest. When pursued from below, flying fish escape the water and extend the chase into the air. A momentary return to the water renews the glide and carries the smaller fish beyond the hunter's reach.
When a pursuit fails, the hunters conserve energy and return to the floating habitat where other opportunities may appear.
Above waters thousands of meters deep, generations of sperm whales move together while searching for widely scattered prey. The calf depends upon experienced adults while gradually learning the routes and rhythms of the deep Gulf. A powerful dive carries the whale beyond sunlight toward prey located hundreds of meters below. In darkness, the whale navigates and searches with sound, though the signals themselves remain invisible. By day, billions of small animals remain concealed in the depths, forming a living layer detected across the ocean.
Every night, an immense vertical migration transfers energy from deep water toward the surface.
Speed allows tuna to exploit the nightly migration, but coordinated escape prevents every attack from succeeding. Canyons cut into the continental margin and channel food from productive surface water toward the deep seafloor. Here, chemical energy escapes from beneath the sediment and supports life beyond the reach of sunlight. Symbiotic bacteria living inside the tubeworms convert seep chemicals into the energy required for growth. Mussels also depend upon internal bacteria, creating dense communities upon an otherwise sparsely inhabited seabed. Salt released from ancient deposits creates water so dense that it collects upon the seafloor like a lake beneath the ocean. The pool itself is hostile to most animals, yet its narrow edge supports organisms adapted to extreme conditions. Where currents cross exposed rock, slow-growing corals create three-dimensional shelter far below the sunlit reef. These fragile coral gardens provide feeding and resting habitat for animals distributed across the continental slope. This ancient shark usually remains in the depths, where a flexible diet and efficient movement conserve energy. Within a restricted region of the Gulf lives one of the rarest great whales on Earth. Evidence suggests that these whales descend to feed near the bottom and return regularly to breathe at the surface. Each breath reveals a survivor whose entire population depends upon this single marine region. When a current bends away from its path, enormous rotating eddies carry heat and life across the Gulf. Approaching Florida, the Gulf narrows and accelerates beside one of the region's most dramatic underwater boundaries.
At the western edge of the Florida Keys, isolated islands rise, where Gulf currents meet a chain of coral reefs.
Clear, moving water supports a vibrant community at the meeting point between the Gulf and the Florida Reef Tract. Beyond dry tortugas, the journey continues through seagrass nurseries, mangrove islands, coral channels, and the powerful current of the Florida Straits. Beyond the Florida Straits, an immense shallow bank rises from the deep Atlantic and transforms the color, temperature, and movement of the sea.
Along the bank's western margin, mangrove channels create protected nurseries only a short distance from the powerful Gulf Stream.
Tangled roots divide the flooded forest into countless shelters where young fish can grow beyond the reach of larger predators.
Young lemon sharks return to shallow nursery habitats where warm water and abundant prey support their early development.
The hunter possesses speed, yet the structure of the forest gives smaller fish several routes of escape.
These large marine snails graze upon algae growing across the bottom and help recycle nutrients within the shallow bank.
Sensitive organs detect concealed prey before powerful jaws crush shells hidden below the surface.
Bonefish follow the rising water into feeding grounds too shallow for many of the predators waiting beyond the bank. Electroreceptors spread across the hammer-shaped head allow this shark to investigate signals hidden beneath the seafloor. An early warning gives the ray enough time to abandon its camouflage before the shark reaches striking distance. Across the Bahamian banks, submerged caverns appear as dark windows into limestone shaped during ancient periods of lower sea level. A few meters below the bright bank, steep walls lead toward a confined environment with less light and weaker circulation. Water of different salinity forms a shifting boundary that distorts light and limits the mixing of oxygen into deeper layers. Isolated passages support specialized animals whose reduced eyes and pale bodies reflect generations spent beyond sunlight. The dark cavern remains connected to the open sea, where tides exchange water and carry small organisms across its rim. During a brief seasonal window, normally solitary groupers travel toward traditional sites used by generations before them.
Before continuing across the reef, the large fish allow tiny cleaners to inspect areas they cannot reach themselves.
The concentration attracts attention, yet healthy adult groupers remain powerful animals rather than easy prey. A rapid change of direction defeats the larger hunter before it can isolate a single individual. Where waves cross the bank's outer edge, corals create a living barrier between protected shallows and the deep Atlantic.
Branching colonies absorb the force of each wave and provide narrow refuge unavailable upon exposed limestone.
And strong fused teeth remove plant growth from the reef and gradually convert carbonate rock into new sand.
Precision and powerful jaws allow the triggerfish to exploit armored prey that many reef animals cannot approach.
The pointed mouth allows the turtle to remove sponge tissue from crevices inaccessible to larger reef animals.
Pigment, skin texture, and posture change together, concealing the octopus against each new surface.
Rapid color changes communicate courtship, warning, and social position without producing a sound.
When daylight fades, the animals that construct the reef emerge to capture microscopic food carried through the water. Nocturnal suspension feeders occupy the highest surfaces, where moving water delivers the greatest concentration of food. Tiny organisms produce momentary light when the surrounding water moves, creating signals that vanish almost immediately.
Across the central Bahamas, hundreds of low islands divide the shallow bank into sheltered channels and exposed tidal passages. Isolated islands protect distinctive reptiles adapted to heat, drought, salt spray, and limited freshwater.
After traveling across open water, tropical seabirds return to inaccessible island cliffs to reproduce.
Each tidal pulse reconnects isolated pools and allows young fish to redistribute throughout the flooded forest.
Rare young sawfish depend upon shallow mangrove habitats, where larger marine predators have limited access.
Sensitive pores reveal movement nearby, yet detection does not guarantee a successful encounter. Along the largest island in the Bahamas, an extended reef system stands beside one of the region's most dramatic changes in depth. A deep submarine basin cuts into the surrounding banks and brings oceanic conditions close to protected shallows.
Deep channels surrounding the Bahamas provide specialized whales with reliable access to squid living far below sunlight. Young whales remain near experienced adults while developing the strength and coordination required for future deep dives.
A controlled descent carries the whale hundreds of meters beneath the surface, where pressure rises and light disappears. Small animals concentrate at depth during the day, creating a major source of energy for larger oceanic hunters. As darkness reaches the surface, an immense vertical migration draws predators upward from deeper water.
Rapid acceleration and sudden changes of direction help the squid survive within the exposed open ocean environment.
Strong social bonds keep the pod together, while individuals search across an immense three-dimensional habitat. Coordinated diving allows the group to explore several layers while maintaining contact through sound that remains unseen. Clear bank water provides these dolphins with an open landscape where prey movements can be followed across great distances.
Play develops timing, agility, and social understanding that will later support coordinated hunting. Some Bahamian dolphins use specialized bottom foraging techniques, learned through observation and repeated practice.
Early attempts often fail, yet each mistake refines the movements required for this demanding technique.
At the boundary of deep water, drifting seaweed forms a mobile refuge for animals unable to survive in the empty ocean alone.
Young turtles use these drifting habitats for shelter, food, and transport during their first years at sea.
Pursuit from below drives the smaller fish into the air, extending a marine chase above the waves.
A brief contact with the water renews the glide and carries the escaping fish beyond the predator's final acceleration.
Far from reefs and islands, the oceanic whitetip searches a vast environment where food may be separated by many kilometers.
The school responds before the shark reaches striking range, forcing the hunter to conserve energy and continue searching. The tiger shark moves easily between shallow banks and deep channels, investigating a wide range of habitats and possible food.
Predators and potential prey frequently share the same habitat, without every encounter becoming a hunt.
The hammerhead patrols the bank boundary, where rays, fish, and ocean currents move between shallow and deep water.
Across the southern archipelago, dry islands, hypersaline lagoons, coral reefs, and open ocean channels remain connected by wind and current. Beyond the Bahamas, the same moving water leads toward Turks and Caicos, where one of the Atlantic's largest shallow banks meets the open ocean.
Unlike the volcanic islands farther south, Anguilla rises from ancient limestone shaped by waves, wind, and tropical rain.
Water crossing the bank loses energy, creating calm shallows where seagrass and young marine animals can survive.
Branching corals absorb the force of incoming waves and create narrow refuge for hundreds of smaller animals.
Broad fins convert gentle currents into lift, allowing the rays to cross the shallow bank with minimal effort. Only the eyes and breathing openings remain exposed, while color and sediment conceal the resting ray. The conches graze across the meadow, while their shells become moving surfaces for an entire community of smaller organisms. Every rising tide reconnects the lagoon with the sea and carries nutrients, plankton, and young fish into the flooded forest.
Warm shallow water provides young sharks with abundant food and limits the movements of larger predators.
A difference of only a few centimeters transforms the lagoon floor into an effective escape route.
Seasonal ponds concentrate salt and food, attracting specialized birds capable of feeding in extreme coastal conditions. Remote offshore islands provide nesting and resting habitat beyond the reach of most terrestrial predators.
Only a short distance away, higher land alters rainfall, runoff, and the shape of every coastal habitat. The meadow slows water near the bottom and provides food, shelter, and nursery space beside the reef. Repeated grazing maintains patches of young vegetation that contain more accessible nutrients than older blades. Hard corals construct the foundation, while flexible fans and filtering sponges occupy surfaces exposed to passing currents. Precise fins allow the angelfish to inspect complex surfaces without touching the surrounding coral. Color, skin texture, and posture change together, matching the octopus to each new section of the reef.
Rapidly controlled pigment cells transmit courtship, warning, and social information without producing a visible signal in the water.
The shark searches for an isolated individual, but synchronized movement hides each fish within the larger formation.
The school changes direction faster than the larger predator, ending the pursuit before valuable energy is lost. Saba is the exposed summit of a volcano whose underwater slopes descend rapidly into the surrounding sea.
The absence of a broad coastal shelf brings deep ocean currents close to reef communities surrounding the island. At greater depth, wide horizontal colonies maximize the amount of light reaching their living tissue. Moving water concentrates plankton along the slope, attracting schools that connect widely separated coral outcrops. Slow-growing suspension feeders occupy positions where ocean water continuously delivers microscopic food. For a few minutes, a powerful predator accepts the attention of fish small enough to become prey.
A specialized mouth allows the turtle to remove food from crevices inaccessible to broader-jawed animals.
The fading light releases nocturnal plankton and begins a transfer of energy from hidden spaces into open water. The school remains compact as faster hunters test its edges for a fish separated from the group.
Open channels become travel corridors, where social protection is especially important for inexperienced young dolphins.
Another volcanic summit interrupts the current, linking terrestrial forest, dark lava coast, and tropical reef. Old volcanic rock provides a hard foundation upon which new biological structure can slowly develop. Each eel remains anchored inside its burrow, while passing water carries food within reach. Carefully selected material reinforces the tunnel and protects the fish when danger approaches. A protective bony shell limits body flexibility, making precise fin control essential for movement.
Irregular skin, muted color, and complete stillness disguise the predator without any need to pursue prey.
The barracuda depends upon surprise, and the early response of the school removes that advantage.
Darkness transforms resting sharks into active bottom hunters, guided by scent and sensitive electrical organs.
Long antennae detect obstacles and help each lobster maintain contact with the animal ahead. On a precisely timed night, synchronized spawning sends the next generation away from the crowded parent reef.
Mountainous terrain creates sharp contrasts between exposed Atlantic shores and calmer habitats facing the Caribbean.
Connected habitats allow young fish to move between feeding grounds and shelter as the tide changes. Short feeding dives alternate with surface breathing as the turtle gradually builds strength for longer journeys. Every fish responds to its nearest neighbors, turning individual movement into a coordinated defensive system. A moving shadow gives the school only seconds to respond, yet that warning is often enough. The flooded root system combines dense shelter with narrow hunting corridors used by both prey and predators.
Complex structure interrupts the pursuit and allows the smallest animals to escape through routes unavailable to the hunter.
Small offshore islands provide seabirds with secure resting places beside productive ocean currents. Steep underwater slopes bring squid-rich depths close to land, creating reliable feeding corridors for deep-diving whales.
The young whale remains surrounded by experienced adults, while its breathing, strength, and coordination continue to develop.
The nightly migration of deep-water animals delivers concentrated food into the range of fast oceanic predators.
A pursuit begun underwater continues above the waves, where distance depends upon speed, wind, and precise timing.
Here, active geology continues to reshape the island, carrying new mineral material from mountain slopes into coastal water. Young seafloor begins as bare mineral surface before currents, microorganisms, and drifting larvae establish new life. Early colonists stabilize the surface and gradually create conditions suitable for increasingly complex communities.
Given time, hard volcanic terrain becomes concealed beneath living structure shaped by light and current.
The edge concentrates movement between shallow shelter and open ocean, making it a natural patrol route. Short journeys between contrasting habitats connect feeding areas distributed across the island's irregular coast. Farther south, volcanic mountains and low limestone country meet within a single archipelago surrounded by reefs and deep channels. The journey now enters a region where rainforest rivers, volcanic slopes, sheltered wetlands, and open ocean.
St. Vincent rises directly from the sea, joining high volcanic forest with a narrow and rapidly deepening coast.
Below the waves, ancient volcanic rock forms steep passages connecting shallow coastal habitats with the open Caribbean.
Each eel remains anchored inside a permanent burrow, while passing water delivers microscopic food.
Strong water movement supports suspension feeders and gathers drifting plankton above the exposed reef face. Color, texture, and complete stillness conceal a predator that can wait for prey to approach within striking distance. Its pointed beak extracts food from crevices inaccessible to animals with broader jaws.
For several minutes, a large predator suspends normal hunting behavior and allows tiny cleaners to approach.
A mosaic of connected habitats provides young fish with food, concealment, and multiple escape routes. The windward coast receives the full energy of the Atlantic, creating feeding opportunities for seabirds above turbulent water.
Deep passages between islands become travel corridors, where social coordination protects inexperienced young dolphins.
Here, submerged ridges rise close to the surface, dividing open ocean into a complex labyrinth of reefs and channels. Sunlit shallows connect feeding grounds, nursery habitat, and reef shelter across only a few meters of depth. Repeated grazing maintains patches of young vegetation and releases nutrients used by smaller inhabitants. Electrical receptors reveal prey concealed beneath sediment that appears empty from above. During daylight, these bottom-oriented sharks conserve energy inside shaded reef shelters. Branching colonies absorb wave energy while creating protected spaces within one of the reef's most exposed zones. Continuous feeding prevents fast-growing algae from occupying every available surface needed by young corals. The open jaws circulate water across the gills, while tiny cleaners remove food fragments and parasites. Movement is slow but powerful, allowing the conch to cross open sediment between scattered feeding patches. Even a small mangrove forest creates a vertically divided nursery used by both developing prey and young predators. Color patterns communicate identity, courtship, and warning without interrupting the group's precise formation. Complex reef structure breaks the line of pursuit and removes the hunter's advantage of sudden speed.
Isolated islands provide resting and nesting habitat, beside channels where surface fish remain abundant.
The pursuit moves from water into air, where wind and wave height determine how far each fish can travel.
At the southern end of the island arc, mountainous Grenada rises between shallow Caribbean banks and deep Atlantic passages. Moisture captured by volcanic mountains creates freshwater roots that connect high forest with the coastal ocean. Runoff briefly changes coastal salinity, visibility, and nutrient concentration before mixing with the surrounding sea. Converging water concentrates plankton and creates a temporary feeding line along the coast. Over centuries, living growth conceals the dark rock and transforms a mineral surface into complex habitat. The meadow supplies food for the turtle and shelter for fish still too small to remain safely on the open reef. Pigment cells adjust to the background, reducing the shadow and contrast that could reveal the fish. Selected pieces stabilize the tunnel and provide a clear defensive boundary around the fish's shelter. Pigment, posture, and flexible skin work together to conceal the octopus across rapidly changing terrain. The reef edge concentrates movement between shallow shelter and open ocean, creating a natural patrol route.
Synchronized movement prevents the predator from maintaining focus upon a single individual.
With daylight gone, hidden suspension feeders expand into the current and collect drifting organic material.
Long antennae detect obstacles and help the animals maintain contact while traveling through darkness.
The coral colony changes from a sunlit partnership with algae into an active nocturnal feeding system. Closely bonded groups cross the channel together while searching above depths occupied by squid. The island arc now approaches South America, where Atlantic currents meet reefs influenced by a vast continental coast. Tobago stands between contrasting water masses, producing sheltered Caribbean habitats and current-swept Atlantic reefs. Closely connected habitats allow marine animals to change feeding ground and shelter within a single tidal cycle. Long-lived colonies add height and shelter to a reef protected from the strongest Atlantic waves. Powerful fused teeth remove plant growth and produce fine sediment that becomes part of the surrounding seabed. The meadow functions as both feeding ground and nursery beside the more exposed reef. Tidal water carries oxygen and food into a forest that protects young fish during their most vulnerable stage. The mangrove's complexity interrupts the pursuit and gives the smallest animals routes unavailable to the hunter. Along the island's outer current, a wide-ranging filter feeder searches for concentrated patches of plankton. The school reduces its exposed surface, while the hunters repeatedly test the moving formation. A fraction of a second and one piece of reef structure determine whether the pursuit continues or fails.
After years in the open ocean, the female returns to tropical sand to begin the next generation.
Careful movement conceals the chamber and leaves the developing eggs protected beneath warm sand. Remote cliffs provide seabirds with secure resting sites beside productive Atlantic feeding grounds.
Aerial movement may assist communication and help the traveling group maintain social contact across the open sea.
Ahead, water arriving from South America begins to alter salinity, visibility, and productivity across the southern Caribbean. Only a narrow passage separates this island from South America, placing Caribbean wildlife beside a continental ecosystem. Fresh water from the nearby continent enters a semi-enclosed sea and creates conditions unlike the clear reefs farther north. The estuarine forest protects young animals adapted to daily changes in salinity, temperature, and visibility. Nutrient-rich mud supports small crustaceans whose pigments contribute to the birds' extraordinary color. The island journey reaches a continental frontier where rivers, wetlands, reefs, and open ocean exchange life across every changing tide. Along Trinidad's northern coast, steep rainforest mountains create a narrow meeting place between terrestrial and marine ecosystems.
Submerged cliffs guide moving water upward, concentrating plankton and attracting fish from the surrounding sea.
Marine growth occupies every stable surface, but only flexible and firmly attached organisms survive near the turbulent coast. The school responds before the hunter accelerates, tightening its formation and moving toward complex shelter. Rock structure interrupts the straight pursuit and gives the smaller fish several escape routes at once. Built for oceanic travel, the leatherback crosses entire basins while searching for drifting jellyfish.
Currents gather delicate animals into temporary concentrations that become both shelter and feeding grounds.
The specialized structures inside the mouth help this turtle handle soft prey that offers little energy in each capture. Twice each day, the boundary between land and sea moves across sediment filled with hidden life.
Different beak shapes allow several bird species to forage together while searching at different depths.
The roots provide a permanent surface for filter feeders and a protective maze for developing fish. Low visibility favors sudden acceleration, but the dense root system limits the distance available for pursuit. A coordinated escape transforms one visible target into hundreds of unpredictable movements.
These small dolphins occupy shallow tropical coasts where river water continually mixes with the sea.
Changing visibility demands close coordination as the pod follows fish through water influenced by distant rivers. One of South America's greatest rivers reaches the sea through a moving labyrinth of mud, roots, freshwater, and tides. Fine sediment and dissolved nutrients continue their journey offshore, altering light and productivity across a vast coastal region. Salinity, temperature, and visibility change across a front that may shift position with every tide and rainfall event. Microscopic animals transform river-supported productivity into food available to larger inhabitants of the coastal sea. Small schooling fish gather where plankton is concentrated, creating a moving link between microscopic production and large predators. From the air, each pelican selects a dense patch before using gravity to enter the water at speed.
Attacks arrive from above and below, forcing the school to reorganize continuously within the shallow water. And unlike most sharks, this adaptable predator can tolerate major changes in salinity while moving between river and sea.
Reduced depth favors the smaller fish, allowing them to escape beyond the shark's most efficient path.
In sheltered water, this rare herbivore depends upon connected feeding areas and undisturbed tidal routes.
The calf learns the hidden channels by remaining close to an experienced adult during every movement and surfacing.
A living coastline begins when drifting seedlings find sediment stable enough for their first roots.
Within hours, the falling water reveals a feeding surface used by animals that survive between flooding and exposure.
Different feeding techniques divide the wetland's hidden crustaceans between birds sharing the same tidal flat. River, forest, and ocean remain connected by tides that carry water, nutrients, and migrating animals in both directions.
This narrow mountainous peninsula separates clear northern water from the estuarine conditions created farther south. Beyond the strongest river influence, improved light allows familiar Caribbean reef communities to return. Each species occupies a different layer of moving water and collects plankton of a suitable size. 3 camouflage systems work together as the octopus passes across backgrounds that offer no permanent hiding place. The predator imitates both the color of its surroundings and the movement of a small potential meal. Temporary cooperation allows tiny shrimp to approach a predator and remove edible material from difficult surfaces. Specialized feeding reduces competition by giving the turtle access to food hidden deep inside reef crevices.
Seasonal upwelling carries deeper nutrients toward the light, increasing productivity across the coastal sea. Upwelling supports immense schools, whose collective movement transfers ocean productivity toward larger hunters.
The dolphins coordinate their approach, but the school responds as one moving structure rather than isolated individuals.
Predators arriving from 2 directions briefly trap the fish within the brightest and most exposed layer of water.
Once the school regains space, its formation spreads and the hunters lose the concentrated target.
Farther west, reduced rainfall creates a drier island landscape beside seas still enriched by seasonal upwelling. Slow-moving conches graze across the meadow, while their heavy shells provide protection in exposed shallows. Sensitive receptors detect hidden animals beneath sediment, guiding each ray toward a location invisible from above. A grasping tail holds the seahorse in position as its narrow snout collects individual prey from moving water. Rapid pigment changes communicate courtship, rivalry, and direction without requiring physical contact. The productive current attracts a wide-ranging filter feeder, able to cross hundreds of kilometers between feeding areas. Fast hunters patrol the shifting front, where prey becomes concentrated between contrasting water masses. The school uses both collective movement and changing water clarity to break the hunter's visual focus. A vast reef complex rises from the Caribbean, forming a shallow world of lagoons, mangroves, seagrass, and coral. Sunlight reaches every shallow surface, supporting coral growth across a landscape continuously reshaped by waves. Strong branching structures reduce wave energy and create refuge within one of the reef's most turbulent zones. Several herbivores divide the reef surface, preventing algae from dominating every space available to young corals. The meadow provides food for large grazers and shelter for fish preparing to move toward the outer reef. Protected shallows offer young sharks abundant food while excluding many larger predators from the nursery. The same mangrove habitat that supports the hunter also provides its potential prey with complex shelter. Wide pectoral fins transform each current into lift, allowing the rays to move efficiently between distant feeding grounds.
Synchronized spawning allows countless colonies to reproduce during a brief period when currents and temperature are favorable.
The journey continues westward toward dry islands, where exceptionally clear water reveals reefs descending directly into the deep Caribbean.
Bonaire's arid landscape releases little sediment, allowing sunlight to penetrate deeply across reefs growing close to shore. Only a short distance from land, the shallow platform supports a living reef before falling abruptly into deeper water. Long-lived colonies build a complex surface that absorbs wave energy and creates thousands of small shelters. Traveling together allows these herbivores to reach exposed feeding surfaces while reducing the risk faced by each individual.
By removing algae and weathered limestone, parrotfish help create open surfaces and contribute new sand to the seabed.
Its narrow beak reaches food concealed within spaces inaccessible to most larger reef animals.
At the drop-off, rising currents deliver plankton from deeper water and attract fish into distinct feeding layers. The reef edge provides a predictable route where the shark can monitor animals moving between shelter and the exposed sea.
Continuous reorganization prevents the hunter from isolating a single target within the moving school.
Away from the exposed wall, the meadow forms a quieter habitat, built by rooted plants rather than coral colonies.
Regular grazing removes older growth and encourages the production of tender vegetation across the feeding ground.
The mangrove margin protects young fish until they are large enough to cross the open meadow and join the reef. Stillness and camouflage allow the young hunter to approach, but every route becomes a possible escape barrier. A single coordinated turn carries the school into passages too confined for the larger predator. Even hypersaline shallows contribute to the island's marine web by supporting organisms adapted to extreme conditions. After darkness, hidden animals expand into open water and transform the familiar reef into a new feeding community. Pigment, posture, and flexible skin allow the octopus to disappear repeatedly across completely different backgrounds. Chemical light carries reproductive signals through darkness without illuminating the entire reef. Only a short distance beyond the reef wall, oceanic depths provide hunting grounds for animals adapted to darkness and pressure.
The same arid climate continues across Curaçao, preserving clear water around a more varied coastline of cliffs and protected bays.
Along the windward coast, constant Atlantic energy creates conditions too turbulent for delicate shallow colonies.
Low-growing forms survive by remaining close to rock, where the force of each breaking wave is reduced.
Only a few kilometers away, protection from prevailing waves allows taller and more delicate reef structures to develop.
The steep slope divides moving water into feeding zones occupied by species with different swimming abilities. The repeated signals establish a temporary truce between animals that would otherwise avoid such close contact.
The eel pumps water across its gills as the shrimp search surfaces protected from almost every other small animal. Camouflage removes the predator's recognizable shape before its lure begins to imitate a tiny drifting animal. The smallest change in angle exposes the deception and ends the ambush before the predator can strike. Color changes transmit courtship, rivalry, and direction through signals that may vanish in an instant. A narrow shelter reduces exposure to currents and conceals the developing young from passing predators.
Two fast hunters test the school from different directions, forcing thousands of fish into a smaller defensive formation.
By splitting at the reef edge, the school creates two moving targets and breaks the coordinated pursuit.
Beyond the reef, strongly bonded families cross oceanic water while searching above deep habitats occupied by squid.
The island chain continues westward toward Aruba, where wind, waves, and aridity shape another contrasting marine landscape.
Persistent wind and surf reshape the island's windward margin while transporting broken limestone toward calmer water.
Protection from the strongest waves allows rooted vegetation and young corals to share the sunlit shelf. Large grazers remain active above the grass as buried rays conserve energy and wait for safer movement. Water drawn through openings behind the eyes allows the ray to breathe even while much of its body remains buried. Sensitive receptors guide the rays across the seabed, while broad fins convert steady current into efficient forward lift. Where moving water meets the headland, plankton and small fish become concentrated within reach of aerial hunters.
The bird uses height and gravity to enter the water, but the school begins escaping before its bill is fully submerged.
Instead of pursuing immediately, the predator uses stillness and reflective light to conceal the distance between itself and the school. Complex reef structure turns one open pursuit into hundreds of separate escape routes. Darkness allows the lobsters to leave their shelters and navigate together across ground exposed during daylight. The reef's builders become active hunters after sunset, collecting particles too small to be seen from the surface. South America returns ahead as one of the Caribbean's driest coasts rises beside a seasonally productive ocean. Wind-driven upwelling carries deep nutrients towards sunlight and changes the color, temperature, and productivity of the sea. Microscopic life responds first, multiplying within water enriched by nutrients transported from darkness. The new production is gathered into moving schools that carry energy from plankton toward larger animals.
The dolphins do not rush blindly. They shape the school gradually until its escape routes begin to narrow.
Pressure now arrives from air and water, concentrating the fish within a rapidly changing layer of light.
Once the formation regains space, the hunters can no longer maintain control over its direction.
The same productivity that supports sardines also attracts the ocean's largest fish, a slow-moving filter feeder.
A moving giant becomes temporary habitat, carrying smaller companions through a sea shaped by shifting currents. Here, one of Earth's highest coastal mountain systems compresses desert, forest, river, and sea into a remarkably narrow region. Rain captured by the high forest travels rapidly downhill and briefly changes salinity along the coast. The meeting of fresh and salt water forms a temporary feeding line used by fish adapted to constant change. Within each protected bay, several ecosystems lie close enough for animals to cross between them during a single day. Connected habitats allow the turtle and reef fish to change feeding grounds without crossing a wide expanse of exposed water. From the dry southern islands to Colombia's rising mountains, wind and current have connected every reef, lagoon, forest, and open water